everyone. Welcome to the physics lab, physics 102. Today we will discuss the experiment number E07. The title of the experiment is to determine the RC time constant in an RC circuit. So let's discuss what is the experiment name means to us. So we have RC time constant in an RC circuit. So what does RC circuit mean? We have a circuit which contains a resistor, which is R, and a capacitor, which is C. So you already know, if you connect R and C in a series circuit and apply some DC voltage, the capacitor will charge with respect to time, and then if you remove the power supply and again complete the circuit, the capacitor will discharge. So from charging and discharging process, we'll find out what is the time constant. Now let's discuss what is time constant. Now time constant is the time required to charge the capacitor approximately 63.2%. So that's the time basically to charge the capacitor 63.2%. Now let's see what is the circuit looks like in our experiment. So this is the circuit looks like. Here we have a switch, we have R, we have a C, this capacitor, and we have a DC power supply. So in our experiment, we will use the resistor, the value will be 220 kilo ohm, and we will use a capacitor, the value will be 330 microfarad. And in our experiment, we will use a power supply, this is 10 volt. So this will be our component. Now let's see how physically they look like. So this is our resistor. So this is the resistor, and again resistor have no polarity, so you can connect in both ends. So this is 220 kilo ohm. Also we have a capacitor. So this is our capacitor. Now if you check closely here, it's 330. Yes, you can see 330 microfarad is written here. Also you can see this is the negative sign is given, so basically this end is the negative end, this is the positive end for our capacitor, because capacitor has polarity. Now let's check which is our power supply. So if you check, this is our power supply, and we will use this the one. So this is will give us the voltage, which will be the 10 volt. Now let's see our circuit. So here we will connect our circuit. So this is called a breadboard where we will connect the circuit. But one thing to remember, you will see here all the column are connected inside, but all the row they are not connected, they are disconnected. So let's connect our circuit according to our diagram. So if you check the diagram, let's put the diagram here, so we can check and compare and we can connect. So we have resistor at first, so let's connect the resistor. This is our resistor, so connect the resistor here. So this is resistor, and we have a capacitor. So again this is the positive end, so let's do positive end here, and let's the negative end here. So you can see I can connect in a single row, that's means they are connected internally. So this is my series connection, and then I need a simpler power supply. So for power supply, look, this is my power supply, and you can see in a power supply, this is the red end, this is my positive end, and this is my. Now let's continue. So this is my circuit, and I told you, so this where it will act as a key for us. So I will connect this one here. Okay, so this is happening. So this is my positive end, is going resistor, capacitor, and from capacitor it will go through my positive, so negative side of my power supply. So let's say this is my negative side of the power supply. So I will connect this one here. So let's say I connect here. So check this not connected because these two are not connected. So if I connect this one here, so those two, the full circuit will be connected. So to me this is the key. So I will connect here and then this will act like a key. So this is our circuit for charging a capacitor. Now when I will discharge the capacitor, what I will have to do, I will disconnect my power supply from here. So I will disconnect the power supply, and instead of power supply I will just short circuit it by this wire. So I will just replace the power supply just by a wire, so then the capacitor will discharge through the wire. Okay. Now after that I want to calculate what is the voltage drop across the capacitor. So for this reason I need a multimeter. So for this multimeter, again it's a digital multimeter. So in the multimeter you have to remember the arrowhead should be here. So this is the voltage. So again I can measure 20, maximum 20 voltage. If I put it here, it makes me 200 voltage. And also you will see my multimeter also has a positive and negative end. So you can see this is my positive end, this is my negative end. So I will connect my multimeter accordingly. So the positive end of the multimeter should go to the positive end of my capacitor, and the negative end should go to the negative end of my capacitor. So check this, my positive end of my multimeter. So positive end should go there, and the positive end should go to the positive end. So this is my positive end of my capacitor, it should go there. And this is my negative end. So negative end of my multimeter should go to the negative side. So this is my negative side. So I will connect it here. So those two end, this one and this one, okay, those just our multimeter to check the voltage drop across the capacitor. So now check our circuit together. We can put our circuit side by side and our multimeter to check our reading. So let's see. If I turn on, you see my value should be almost 0, and also my power is still off because it's not connected. Now let's go to our experimental sheet. So let's try to focus here for time being. So this is our experimental material. So this is the circuit we already discussed. Now there is some theoretical part, it's already given. So if you solve the theory, what happened, we can derive the equation, and from the equation we can find some relationship, and if you draw this one will look like this one. So this is the equation will look like this. So again this is the ln 1 minus Vc by epsilon naught. So this term versus the time. So if you draw, it will be this kind of graph, and if you draw Vc from the equation versus time, so it will look like this kind of graph. So Vc by time, this is the graph of this one, and if you draw this one, it will be this one. So those are the two graphs for charging the capacitor we can draw from our data. And when you discharge, this will be our circuit look like. So there is no power supply, so power supply will be short circuit by just single wire. And again we can do the same procedure. So this will be our discharging curve. It will look like this. So Vc versus time, and again this will be our this curve, and this is, so from this curve I can find the slope. This is slope, and also from the first curve here also I can find the slope m. So again it will be curve. If you take any point and if you draw a tangent, and from the tangent we can draw the tangent, the slope. Here we can do the same thing. So now what is our experimental data then? So again if you go there, so this will be our experimental data. So what you want to find out here, so check. So this is the maximum potential difference. So again maximum potential difference using in our experiment. So again we are using 10 volt from our power source. So this is always 10 volt, is a constant, and then those are the time. So again you can see I will take the reading 0 second, 30 seconds, so 30-second interval, and for this reason we have this stopwatch. So I will start the stopwatch, and after 30 seconds I will take the reading. But what kind of reading I will take? I will take only one reading. This is the Vc, this is the voltage. So voltage drop across capacitor, that's all. So just you have to take one reading. So each 30 seconds just you have to write down one value, that's all, nothing else. And this is the calculation. So you have to do this calculation. So 1 minus Vc, so this is the Vc for each value corresponding, and this is the E. So again the 10 volts, a constant. And similarly for the discharging, for each second, for 30-second interval we will take the Vc, that's all. So it will be the charging, and for this discharging, and again this for the calculation, nothing else. So now let's start with our experiment, and let's see how can we take some value. So you will see this is our voltage source. So let's start the voltage source. So you can see this is the 10 volt. So this is our 10 volt. So this is our circuit. This is our voltage, and this will be our data. So for each 30 seconds I will write down some data here. So at first let's make our capacitor discharge fully. So if you want to make a capacitor discharge fully, just connect the two ends like this. So again what we are doing, and then connect again the slot. So let's check, my capacitor now is almost 0, and then this is our timer. So we will start the timer and connect the circuit. So if you want to connect the circuit, just we have to do one thing, we have to connect this one to here. So if you hear this is a key, so the circuit will be connected. So I will connect the circuit, I will start the timer, and then for each 30 seconds I will take the data or reading from my voltage multimeter, that's all, nothing else. So let's start this one. So check, I connected data. Look, this is our timer. So you can see time is increasing, and you can see also my voltage increasing. So for each 30 seconds I will take the value. So for 30 seconds the value was 0. So from the here I will take 30 seconds. So this is 19 seconds. Look, I'm sorry you cannot see the value, but I'll write the value in our sheet and then I will show you later. So this is 3.14 for first 30 seconds. Let's say after 1 minute, what is the value? .2. 8.6, 7.5, 8.15, 8.6, 8.91, 9.15, 9.31, 9.42, 9.52, 9.58, 9.60, 9.62. Now as you can see, the increase of the voltage is really small. That's mean the capacitor is almost becoming fully charged. So let's take another 2 or 3 data, and then we'll start the discharging process again, and similarly we'll take the data as we did for charging scenario. So 9.68. So let's say this is our last data, because it's almost becoming stable. So it's 9.7. So let's stop. So again, this is our charging process. Let's say it's done, almost done. It will leak a little bit, is fine. So what I will do, I will just stop our stopwatch, make it 0. Okay, fine. So let's say 0 again. So what I will do, I will start the discharging process, and then I will take the data on my discharging sheet. So let me give you just leave the idea. That's what I did. So this is our table. So again, for each time, again I take the voltage here. That's the one. So right now I'll go there. So the discharging process. So again, for I'll just count the voltage. I'll start the stopwatch, and again for count the voltage, and I'll take the same amount of data as. Okay everyone, so let's start the discharging process. So for the discharging process, I will again start my stopwatch, and then carefully I have to disconnect my power supply, and this is my key. I will connect the key directly, and then similarly I'll take the reading. So for this reason, let's start the power supply. Disconnect this one is the power supply stopwatch. So I connected. So now let's check. This is decreasing. So let's say 5.4. Okay, 9.5 was my starting point. So 9.68, and then each 30 seconds I will take a reading as before. So let's say this is my timer. This is my. So watch carefully this one, and also the timer. So just turn on the power off the power supply, because I don't need it anymore. So let's write down just the value, 9.68, and then for 30 seconds, okay, 9.5, sorry, 6.5, 4.62, 3.22, 2.22, 4.63, 0.52, .05, 0.71, 0.51, 0.36, 0.25, 0.18, 0.13. So now as you can see that the voltage drop is also really decreasing with respect to time. So that's mean the capacitor is almost becoming discharged fully. Now 0.09. So let's take the last one. So 0.07. Let's take another one, the last. it's yeah 0.05. So that's all. Now let's talk about the data. So our experiment is done. Now let me show you the data table. So this is the data table. So hopefully you can see, and you can zoom in and you can see. So what I did here, so you can see with respect to time I take the charging and also I take the discharging. So let's say 3.6, you can see that, and let's take the rest. So this is our data. So you can pause and you can check the data. So that's all. So this is the whole experiment here, nothing else. Okay, now so how to do the calculation? So for the calculation, go to the last page. With the last page, what you have to do, so that's the one. Charging of a capacitor. So theoretically the time constant tau equal to RC. So again we already know what is the value of R and C in our experiment. So for the R we use 220K and for the C 330 microfarad. So from those values definitely I can calculate this RC. So again do it, and then you have to draw the graph. Which is the graph? The first one. So this is the graph, you have to draw it. So we know the data, so we have the time, and we also have this one from my table. So you can draw this data, and then again you can use the Excel, no problem. Use the Excel, you can use the equation. From the equation you can see the y equal to mx plus c. So mx, so this is basically the value will be there, or also you can draw a tangent and you can find the slope here. So this is our experimental value. So this is the experimental value from the graph. So you can see this will be the tau. This is the theoretical value, and this is the experimental value. Now if you go there, so you can here we can find the error. So what is the error of our experiment? So again, this is tau th. This is the theoretical value, experimental value by theoretical value divided by into 100%. So this is the value you can find out. So do it, and then this for the discharge process. So again, for the discharge process, the time process tau is the same RC. So these theoretical value RC and these value again they should be same because they are the same value. And now this is the experimental. So let's go to the fourth graph. So this is the one. So again you can draw similar graph for the discharging process from our table. So tau inverse this one. So similarly we can find the slope from this graph. So if you do that, similarly we can find this one, and then you can also find the value. Now here tau is just a minus mean here, just a charging and discharging. So that's all, nothing else. So find the tau. So again find the error. So this is the whole experiment. So today I showed you how to find a time constant for RC series circuit for the charging and discharging process. So use the table, and from the table find the data and find the results. So thank you guys, that's all for today. So hopefully you can at home you can practice and you can find the value. Good luck.